Welcome to this video, great to have you on board. Observables are great and operators are too, but it can be hard to find practical use cases for operators because you need some practice to be aware of where you might use them. So let me show you a specific pattern which uses two operators RxJS offers, which is really an awesome pattern which might enhance your application. So here is an example. We have an input field created with the input element, and I'm wrapping the input event with my observable here, where I use the fromEventHelper method to, basically react to every input event, and then I subscribe. So now if I type here, max for example, you see that on every keystroke, the current total value of the input field was printed out. Now that could be useful if we have an application where we want to validate the existence of, let's say, a username on every keystroke. So a user is signing up and we want to tell him right whilst the user is typing if the currently chosen username is available. The issue might be that we of course need to send an HTTP request to our backend to check the existence of the username in our database. Now, if we do that on every keystroke, we're going to send a lot of requests. And for that very reason, we can use RxJS and operators to control how often we do something. The first very useful operator which might help us with that is debounceTime. Let me add it here, debounceTime. It's a simple operator. All we have to do here is we have to pass an argument which describes the time in milliseconds we want to wait before we emit a new value piece, we could say. It'll become more clear once we see it in action. So here, let's say I pass 2000 for 2 seconds, and now you shouldn't get a new value emitted if it's within this time frame. Let me show you how it works. If I hit Control Enter, and I now start typing, watch the console log. You see, nothing happened, but after 2 seconds, we get max. And the other two events, where I typed M and then where we had MA, were simply dropped. And that happens due to debounceTime. Now, you might say, well, that looks a lot like Throttle, where we also could pass a time span, and then it would only emit a new value after this time span has passed, right? It works a bit differently though. Here, a new value will only be emitted if nothing happened for 2 seconds. So this is if I keep typing here and I type and I type and I delete some characters, which is also kind of typing, also firing the input element, you see it never emits the value. We still have max from before. Now only if I stop typing here, now it will wait, and after 2 seconds of no value being emitted, so of me not typing since we emit a new value on every keystroke, we get the current value. And this is what debounceTime does. It simply checks if there has been a pause of value emissions for the time span you specify here, and then it will simply give you the latest value and all the others will be dropped. And that can be very useful because it means that if we set this not to 2 seconds but maybe to 500 milliseconds, then we can really let the user type his name, also let him correct something, but then after a brief pause, we actually get the value. And of course this was not that impressive because I forget to hit Control Enter. So now again, you see I can even delete something, but now if I stop for half a second, we get the value. This is debounceTime, and this is already a great enhancement because if we come back to that example of sending HTTP requests, here we would send only one HTTP request. And even if the user stops for half a second and then continues typing, we might have more, but we don't have as many as if we were to send them on every keystroke. However, we do have one issue here. What if the user decides, oh, I mistyped, and then, oh, I was correct? Now you see, indicated by that 2 here, that the same value was emitted again. Because the user typed something, then he paused for half a second, and as debounceTime does, it gave us the latest value. Here, however, the latest value is equal to the value we had before. And that might be the behavior you're looking for, but it might also not be the case. It would be nice if you could also filter out values which are equal to the last one. And that is what the second useful operator does. DistinctUntilChanged. Now this comes after debounceTime, because if we were to place it in front of debounceTime, we would rarely have a case where the last total value of the input field is the same as now after we pressed a key, right? Because if we press a key, we probably changed something. So after debounceTime though, we can rule out cases like this one. So now if I clear the console and hit Control Enter, and now I type Maximilian, we get Maximilian, and now if I do the same as before, delete that and retype it quickly, you see I still get it. So shouldn't we not get this anymore? Well, yes, but keep in mind, our value of the emission here, so what we emitted, is not the total value of the input field. We get that here with the event target. The value we do get at this point of time is just the event. And the event now, of course, is different to the last one, even if the total value is still the same. So what we can simply do is we can throw in a map before all of that. Map allows us to transform the value. And here we know we get the event, but maybe I just want to return the event target value, which also means down here I get the finished value. So I can now print that. And if I now hit Control Enter and we do the same again, I type Maximilian, we get Maximilian, and if I now do the same as before, you see no new value was emitted because we don't have that 2 next to Maximilian. If I change something else though, we do get it. Because now the value of our emission, of our observable emission here, is the total input, and that now doesn't change if I do this. Here it's still the same, so no new values emitted. So that is how you can cleverly combine a couple of operators, namely debounceTime and distinctUntilChanged, with map to make sure we're using the right value, to maybe enhance your application, and in this case, send only one HTTP request instead of thousands. So I hope this was useful and kind of gets you thinking on how you may use observables, and I can only encourage you to play around with these operators to find out how to best use them.